Welcome to Ganeswar Rasayan. Today we'll start another numerical problem based on empirical formula and molecular formula. First of all, we have to calculate empirical formula, then after molecular formula. Let us know what we mean by this empirical and molecular formula at first. Empirical formula of a compound shows the simplest whole number ratio between the atoms of the elements in the compounds. What about molecular formula of a compound? It represents the actual number of atoms of each element present in a molecule of the compound. And we are going to calculate empirical formula at first, followed by molecular formula. Now, I am coming to procedure directly, and the procedure is a 5-stage procedure. The first step procedure or step 1 is you have to draw 5-column table. The first column element, second percentage composition, third atomic weight, fourth ratio of atoms, fifth simplest ratio. So I am going to explain all steps by using the column number. So I am mentioning this is column 1, this is column 2, column 3, column 4 and column 5. So in the beginning we may be using this column number, but when you will be prompt, you have to avoid, you have to write element, percentage, composition, etc. Because my procedure is based on column only. See, column 1, column 2, column 3. You will get the data from the question only. Elements, whatever the elements will be there from the question only. Percentage composition from the question only. Atomic weight from the question only. That means column 1, whatever you want to write are elements that you will get from the question. Column 2, percentage composition you have to write from the question. Supposed to be percentage composition is not given. Let's say elements percentage composition are not given. See, in such cases, mass of that particular element must be given in the question. You calculate percentage composition, then you enter into the column number 2. Column 3, atomic weight must be given at the end of the question. You put you write or post in column 3. About column 4, this column 4 is always, see, I am writing it from question. So get all this from the question. Column 4 is C2 by C3. The value of column 2 by value of column 3, that means is the ratio of percentage composition to atomic weight. This value divided by this value. Column 2 means percentage composition will be the numerator and atomic weight will be the denominator. And find out C2 by C3, that gives you C4. Column 5 value, this is C5 is equal to value of C4 by lowest value of C4. The most important column is C4 because you are using these values to find out the simplest ratio, where each value are the numerators for column 5 and lowest value of C4 is a denominator for C5. That it indicates the lowest value must be divisible with the rest of the values of C4, or leaving that lowest value, the rest of the values must be the multiple of the lowest value of C4. So, as per the necessity, you can adjust it, correct it, so that it will be, or you should get a whole number at least. Coming to the C5, the importance in that is, you should always get a whole number. Supposed to be you are not getting a whole number, supposed to be you are getting 0.5, one of the value, or one of the value is 1.5, 3.5, like this, exact. In such cases, multiply 2 to all in order to convert into whole numbers. Remember, we are multiplying by 2. Never go with the into 3, into 4, into 8. Suppose 1 is 0.25, then we'll say into 4, it will round up. Not to go up to that. In some cases, you may get exact 0.5 or 1.5, 2.5, one of the value. Multiply 2 to all values in order to get whole numbers. So these are the all steps of procedure. Once again repeating, 1, 2, 3 you are getting from the question. If supposed to be 2 is not available, mass of that element are given, calculate percentage composition, then you post the values. C4 is the C2 value by C3 value, and C5 is value of C4 by lowest value of C4. So you must get a whole number in such cases. And regarding this the value will be the coefficients for your empirical formula. Supposed to be this is x, y, z are 3 elements, and you are getting, let's say, 1, 2, 3 are the coefficients, and finally you are getting C5 value. Here C5 is your 1, or this y is equal to 1, this y is equal to 2, this y is equal to 3. Then the empirical formula will be x1, y2, z3. So that the superscripts for the empirical formula. So you write the element, symbol, then followed by the coefficient. That will be your empirical formula. After calculation of empirical formula, we have to move to the molecular formula if question asked. So in such cases, you must be given molecular formula weight or VD, because it's necessary. It must be given in the question. If supposed to VD is given, multiply 2 to get molecular formula weight, and from this empirical formula, calculate empirical formula weight. Then take the ratio molecular formula weight to the empirical formula weight is equal to coefficient n. So I am writing calculate empirical formula weight. As usual, the process you know to calculate molecular formula, same you apply. Calculate molecular formula weight maybe given directly in the question, or VD must be mentioned. So 2 into VD gives the weight. Then calculate coefficient n. This is equal to molecular formula weight divided by empirical formula weight, and it must be a whole number. N must be a whole number. Suppose we are not getting a whole number, you have done some mistake. So it is giving you opportunity to check your calculation. You start from the beginning, or you start from the here may be the wrong, here may be the wrong in calculation. So it is giving you opportunity to check your calculation. So n must be a whole number. After calculation of n, then you go for determine the molecular formula. So molecular formula could be, let us suppose to be this is your empirical formula, and you got here 2, n equal to 2. So this is 2 into empirical formula, that is equal to x2, y4, z6. This is the molecular formula of that compound. Let us come to the examples number 1 to see. So example 1, a compound of carbon, hydrogen and oxygen is found to contain 40% carbon, 6.7% of hydrogen and 53.3% of oxygen calculate its empirical formula. If its vapor density is 30, calculate its molecular formula. So let us write this are carbon, hydrogen and oxygen. These are the three elements, and percentage composition mentioned 40% carbon, 46.7% hydrogen, 53.3% oxygen. Atomic weight, carbon must be given in the question. I have not written, but you know carbon is 12, hydrogen is 1, oxygen 16. As I said, C4 equal to C2 by C3. So this is 40 by 12. This is 6.7 by 1. This is 53.3 by 60. So 40 by 12, 12 3s are 36. Again 40, so 3.33, let's say. 6.7 by 1 equal to 6.7. So 53.3 by 16, 16 3s are 48. So again 6 3s are 48. So 3.33. So here the lowest value, you can take it as lowest value or you can take it as lowest value, and you have to see the other values must be multiple of the lowest value. So here 6.7, so 3.3 2 ja 6.6, nearly coming, so multiple 3.3 3.3, so multiple. So C5 is equal to C4 value 3.3 by lowest value 3.3 equal to 1. This is 6.7 by the lowest value 3.3 equal to 2. This is 3.3 by lowest value 3.3 is equal to 1. Therefore, empirical formula C1 H2 O1 means this is CH2O. Now coming this up to this point we have completed, calculate its empirical formula. Now it says vapor density is 30, calculate molecular formula. Another 3 steps we have to cover. So empirical formula mass one carbon hence 12 plus 2 hydrogen plus 2 1 oxygen hence 16, so it's coming 30. Molecular formula mass is equal to vapor density is 30, here it is given, so 2 into 30 is equal to 60, 2 into Vd equal to Rmn. Therefore, coefficient n is equal to molecular formula mass by empirical formula mass, that is equal to 60 by 30 is equal to 2. It must be a whole number. If you are not getting a whole number, somewhere you have done mistake. You have to search for that. So therefore, molecular formula is your n into, means coefficient into empirical formula. So that is n equal to 2 into CH2O or okay CH2O, keep it in bracket. So this is actually it should be multiplied to the coefficients or subscripts. So you can write it like this also, into 2. That's a C2H4O2 is the answer. It's the simplest way. You are getting column 1, 2, 3 from the question. C4, column 2 divided by column 3 in all the 3 cases. Then you have to check here, C4 you have to check here. Mark it which one is the lowest value. Then you see the other values must be multiple of the lowest value, so that C5 will be easier. And here we got 3.3, 6.7, 3.3. So one of the value would be the lowest one, 3.3. Then C5 is your C4 values divided by lowest value. So 3.3 by the lowest value, 6.7 by the lowest value, 3.3 by the lowest value. All the cases we are getting whole numbers. C then empirical formula, then to calculate molecular formula or to determine molecular formula, empirical formula must be calculated, then molecular formula mass, it will be given in the question or it will be given, multiply 2 to get RMM or molecular formula mass, then calculate coefficient, second step, and molecular formula is equal to coefficient n multiplied to the subscripts of the empirical formula. That gives C2H4O2 is the answer. Let us come to the example number 2. So, example 2, an inorganic salt gave the following percentage composition: sodium 29.11%, sulfur 40.51%, oxygen 30.38%, and calculate the empirical formula of the salt. So, elements are sodium, sulfur, oxygen. So, sodium, sulfur, oxygen. Percentage composition mentioned to 29.11%, 40.51%, 30.38%. Atomic weight, sodium is 23, sulfur 32, oxygen 60. So, column 4, ratio of C2 to C3. So, this is 29.11 by 23. So, 23, 1 is 23, so 1.2 it will be approximately. 32, sorry, this is 40.51 by 32. This is also 1.2. 30.38 by 16 is equal to, if you divide it will be 1.8. So lowest value is 1.2 obviously. So I am marking this one as the lowest value and I have to check whether the others are multiple of that or not. 1.2, 1.2, multiple, 1.2, 1.8, not exactly, it's coming 1.5. Okay. Anyhow, the value of C4 divided by 1.2, lowest value, is equal to 1. Here also 1.1 by 1.2. 1.2 by 1.2 is equal to 1. Here 1.8 by 1.2 is equal to 1.5. Here is the case. Exact 0.5, 1.5. See, in such cases, multiply 2 to the all values in order to make it whole number. So this is 2, this is 2, this is 3. So therefore, empirical formula of this inorganic salt would be Na2, Na2S2O3, sodium thiosulfate, and this is the answer. Now let us come to the third example. So example 3, a gaseous compound of nitrogen and hydrogen contains 12.5% of hydrogen. Find the molecular formula of the compound if its relative molecular mass is 32. Nitrogen, hydrogen, RAM are given. So here element are nitrogen and hydrogen. 12.5% hydrogen. So rest are nitrogen definitely. So 100 minus 12.5, that is equal to 87.5% is of nitrogen. Atomic weight, nitrogen is 14, hydrogen is 1. So let us calculate C4. So here it is 87.5 by 14. 14 6 ja 84. So it will be 6.25 and calculation. This is 12.5 by 1 equal to 12.5. So lowest value is 6.25 definitely, and 6.25 is at 12.5. So it's a multiple. 12.5 is the multiple of 6.25. So we'll proceed to C5. Lowest value is 6.25, so 6.25 by 6.25, lowest value equal to 1. This is 12.5 by 6.25 is equal to 2. So empirical formula N1, I am not writing 1, H2, so it is NS2, empirical formula. Then we have to calculate molecular formula. So empirical formula mass, 1 nitrogen, 14 plus 2 hydrogen, so it is 16, addition 14 plus 2 16. Molecular formula mass or molecular formula weight, same thing, molecular formula mass is equal to given 32, therefore N is equal to 32 by 16 is equal to 2, therefore molecular formula equal to NS2 whole into 2, that is equal to N2H4. Answer. So you try to complete all ICSE questions last 15 years and other books, reference books questions. If you have any problem, must communicate through WhatsApp. Thank you very much.